Hey everybody, welcome back. I see there's quite a few people already streaming in, but this is Your Desk University, and we bring you live learning with AEC tech experts directly to your desk. We started just about, I guess, maybe 7 months ago or so, just as COVID was starting to hit, and none of us thought this would be so long, but we wanted to find a way to connect people and educate people in the tech community, both in deep dives into technology, like instructional videos and then panel discussions. And we've got 9 more sessions in the fall. And I'm grateful to all the people who are here next to me, shown in the images, who helped participate this. I want to welcome up in the top right, I believe it is your top right, Lisa Marie, who's joining us and who's been helping with some of those highlight videos you've seen. And I think we'll see some more of those coming out. With that, I do want to take a moment to say something about John Skippers. Sorry about your name tag there, John. Got it wrong. Um, but there we go. So John is behind the scenes every time we stream, always doing the audio, checking it. So if there's a problem, you know, he usually lets me know before anything happens. And John, just to say hi to the group here, tell us something that you learned in those first 20 sessions.
Hey, I learned a bunch. I learned about data trees in Grasshopper, some really great nodes in Dynamo, Airtable, which I now use all the time, and most importantly, probably how to troubleshoot repeating audio in YouTube when the pressure's on. So that was a big one.
Thank you. And just as a reminder, definitely check out our website. There's really a lot on there that we've already posted. We posted 9 upcoming ones. Today we'll be talking about Grasshopper. We are for people who are starting to get into Revit plugins. Lisa Marie is going to be sharing a little bit about that, and then Python and data visualization with Boca. Isan, Dimitri, and Guy. I'm so grateful to these guys. Are going to be doing a kind of a roundtable about open source for the AEC community. Speckle's going to be sharing about data sharing, data interoperability between offices, and a different way of looking at things. And then the last one we currently have posted is about Forge apps and BIM 360. Um, Manuel and Viola are really engaging speakers. We haven't posted them yet, but I know there's another one coming up about reality capture. I'm definitely looking forward to that session, and then also some more Grasshopper training, because I know Rhino.Inside. A lot of people are getting into Grasshopper that may have not been there before. Again, we're really not trying to focus on the beginner users, but we're trying to capture people who have already gotten through a computational design course at the beginning and started doing some things, maybe not done a course, but they've already dug into things and trying to learn more, but haven't quite reached software developer, and they're looking for something. So we want to provide for you. You can go to our website. At the bottom, there's a Slack channel. You can join the conversation there. There's 180 people in that conversation. Uh, and we just want to be a service to you. As you can see from the people that were listed, we all volunteer our time to be helping making this happen, and we just want to give back to the community. There's been so many people in this community given to us, and I know like my space and my career right now based on a lot of really great individuals who helped with training. So with that, I'd like to introduce our speaker today. Laura Carnath is our speaker, and she is an architect at Walter P. Moore. She's one of my coworkers, and I'm grateful for her giving us a little bit of time today to talk about Grasshopper and what some of the things she thinks about when she's training people in Grasshopper. So I do think that this is going to be one of those topics that could be highly debated. So I'm going to keep watching that chat. I see a couple more people: Augustina, Lisa Marie, Mark, welcome. I'm going to be watching that chat because I know there's going to be things she says that people are going to say either, oh, there's another way to do this same thing. And when Laura and I were talking about this, like we kind of wanted that. So we encourage those conversations definitely. And I'll be fielding your questions that come in the chat, Laura. So with that, Laura, I'd like to turn it over to you.
Thanks, Timon. Should I share my screen now?
Go for it.
Awesome. Okay, so I like that you said this wasn't for beginners, but my talk is actually for advanced users who are training beginners and working with beginners on their team while they're also trying to deliver a project. So this is based on some of my experience on some of the projects that I've worked on. So I'll start by talking briefly about some of the types of projects we work on. I work in the enclosure group at Walter P. Moore, so we work at a pretty wide range of scales, everything from small artworks to stadiums and airports. So what I'm talking about today is more at the large project end of the spectrum. So when you have this really big project, it's geometrically complex, you're the lead computational designer on the team. You can't really do everything yourself because there's just too much work to be done. And sometimes you have a team that is, not at as high a level as you are on Grasshopper. So what I want to talk about is using the work on that project to bring your entire team up to a higher level. So before you get started, you have to kind of sit down and strategize your project workflow, how you're actually going to do the project. So you ask yourself, what do you need to deliver? So the first project example I'm going to talk about had a primary structure independent of the building, actually, that was supporting this really curved facade. It had a secondary structure grid that was kind of driving the panelization of the facade, and then it had this complex mesh form that was the actual outer enclosure. Um, and then you ask yourself, how can you deliver this with the team that you have? So I'm going to talk about first one of the teams that I worked with on this. So this is my team as we started the project. That's me with the happy face. I'm the computational design lead. Um, and these are the people on our team for this project who were our kind of Grasshopper power users. It was me and it was the project manager. However, the project manager had project manager things to do, and she didn't actually have a whole lot of time to contribute to our Grasshopper workflows, our geometry, our interoperability tools. She had time to kind of review and give input, but not actually to do it. So these are the people who are actually kind of the production team for the project. Um, and so we had a bunch of engineers who were really great engineers, super sharp, but they just didn't have a whole lot of Grasshopper experience, which is why I'm showing them in green here. So this is how we started the project. And I had to think about developing Grasshopper tools and getting these guys up to speed while we were actually doing the work. Unfortunately, you don't always finish the project with the team you started the project with. So we did eventually gain another computational designer, but some of our engineers who had built up all this great experience and knowledge left the team, and we had to bring new people on to train them. So I think one of the really critical components to this is communication and how you keep that common thread going from the beginning to the end of the project so that people can hand off work to each other and understand what they're looking at. So one of the things I wanted to talk about is using project-specific tasks to kind of teach parametric thinking. People who don't have a lot of experience in Grasshopper or similar tools, it can be kind of overwhelming to get started. So I start with them by creating really simple definitions and really simple tools um, that I can then build complexity and flexibility and adaptability onto as the project moves forward and my team gets more experienced. So it's really easy to kind of fall into a pattern of thinking like at the beginning of the project, I have to like account for every possible variable and create this amazing flexible Grasshopper tool that will anticipate everything. And like we all know, that doesn't really happen. And even if it did, you would be depriving the rest of your team of the chance to level up their skills. Um, so this is like a little joke I have with my fellow computational designers. Everyone wants us to deliver the magic button. You press it and it generates all the geometry and it does everything you need to do and poof, the project is done. Amazing. But we don't really do this. This never happens. So how do we get started? So I start with people by, there are a lot of different ways to create geometry in Grasshopper. They can be really confusing. So what we want to do is relate Grasshopper components to building elements. So like you have your grids and levels. A lot of people, I think, have a hard time working with planes if they've just been doing the kind of modeling where you click a point and then you click another point to draw a line. Um, but planes really make intuitive sense as building levels. So that's a really easy place to start. Then we move on to points. So you can define them by an XYZ, you can intersect them with grids, you can project them to a surface. But you really kind of have to get into what you would use this stuff for and what's going to change on the project. So kind of maybe going back to the levels and grids a little bit, something I didn't mention is when we're doing a facade, we're using slightly different levels and grids than the rest of the project. So ours are going to change a lot more rapidly than maybe the overall structural grid. So we have to kind of think about what our inputs are, because a lot of newer users will not anticipate what the inputs are that are likely to change throughout a project. So that's where you're kind of leading people and setting up a workflow that's going to work for them, even if they don't necessarily understand why you're doing it that way at the beginning.
You're kind of like starting
Um,
with these kind of like abstract concepts instead of just like, oh, create a point and create a point and then connect them. You're kind of like thinking more abstractly, but you know it's going to lead them in a direction that's going to be a kind of a more success.
yeah,
For
yeah, and
context, oh, go ahead.
we know that there are like many different ways to do a point in Grasshopper, right? And you want to pick the right one, and you want to anticipate what your needs are going to be in the future on the project when things start adapting, and you want to pick the right one. And that's what you kind of need to help people with, is to think like 5 steps ahead.
Yeah, I was going to say, maybe to help for context, I, I'm imagining, I'm speaking for you, so correct me if I'm wrong, but that until recently, a lot of your Grasshopper use obviously was not connected to Revit. So when you were thinking all these grids and all these, you were just really just working kind of the abstract geometry inside of Grasshopper.
We were really working with the abstract geometry, but if you let me get to the next slide.
Sorry. Okay, let's keep
Um,
going. This is great.
we're going to talk about framing members, because a framing member is not just an abstract geometry of a line or an arc. We have that. That's kind of what we build it from. But then you're also adding a shape, and you're also adding an orientation if you're talking about steel framing, for example. Um, and none of these components say make a wide flange beam. But you can do that with them. And there are also obviously lots of great plugins and tools that will do this. But if you start from kind of the most basic thinking of how you could achieve this without using those plugins, it's good for people to know. And then getting into like looking at different ways of making panels, because we do a lot of that on our facades. Are we constructing the surface? Are we taking a surface from the architect and dicing it? All of that good stuff. And then breaking those back down. So before we did everything by Rhino.Inside, which I don't do everything in Rhino.Inside yet, because I've had some lovely bugs come up the day before the deadline. But you can take that surface in Grasshopper back in the earlier days before we could go straight into Revit from Grasshopper, and kind of break it down into ordered points and build it back up in Revit with adaptive component models. So these are kind of relating the geometry to the building. Um, and next, we started with creating these really simple clusters that are related to building components, so that people could really understand and kind of use them and copy paste them around the canvas. And it's really important to note that it's not how I would do the project if I was doing it myself, but I can't do the project myself because I would never sleep again. So you need to meet people where they're at and give them something a little more basic that they can work with and hack and pick apart and figure out how to modify. So like, you look at this, if I wrote this and I know exactly what every one of these components does and it all makes sense to me, but if I hand it off to somebody else, they might have to spend like 3 hours like backtracking through each component. Okay, what is this one doing? What is this one doing? What is this one doing? So a lot of this is just organizing your thoughts so that people on your team can kind of think the same way that you're thinking, because everybody is going to do their grasshopper differently and organize their canvas differently. And when you're kind of sharing work on a big team like this, and somebody leaves the team to work on another project, someone else has to pick up that person's work, and if you have this massive spaghetti mess, it's going to make your life really difficult. So instead, we might have something like this. So on that project that I was mentioning earlier, we started at the beginning by making these super super simple little clusters and super simple inputs that would do really basic things that are related to a structure. So we have different kinds of braces, we have different kinds of columns, we have different kinds of beams, um, and they put together this little model that you see on my screen. Is this like the most Grasshopper component efficient way to do this model? Probably not. Um, but it makes intuitive sense to people, and someone can open that brace component and say, oh, this is how I would construct a brace. Well, I need my brace to do something a little different. So maybe if I change how this is done, I can make something else. So that may be controversial. It's not how I do it on my own, but it's how I could get people on board. So these are some of our column components that I made, and it gets people thinking about how you construct this stuff and how you construct it in a way that it's adaptable. So like really simple, this just makes a one-off column. And on this project, that made sense because the geometry was very irregular. So we weren't doing like a whole blanket of stuff on the primary structure. Starting to layer on data trees and lists on top of that so that you can make multiples. Um, Looking at when the geometry doesn't behave the way you think it would, like if you need to make sloped columns and different methods of doing that. So we went through and made all of these little components. So different kinds of beams from columns and levels, or just endpoints of columns. You can make a slope beam, etc. And braces that can flip back and forth. So like adding Boolean toggles to flip something back and forth, people start to understand how you can use those. So there's a lot of different things you can learn from this. And so this project, this was our kind of component canvas for the secondary steel on this project. And I'm not going to get into the weeds of any of these components because they're kind of too project specific to be meaningful to anyone else. Um, but we set up at the beginning, here are some basic components. This is the basic construction of what we're doing. You can use this component to make the secondary structure. But everybody's going to run into situations where the pre-existing components don't really work for them. And so then they have to dig into it and hack it and take it apart and figure out how to make it work a little differently. And so the process we used for that is either I would come and sit with someone while they picked it apart rather than them saying, well, I need it to work like this. And then I make them a new thing and hand it over. I would sit with them and we would go through each little Grasshopper component and figure out um, what does this do? Why are we using this one and not that one? Um, and then once they're done making something, I would vet it and then put it back onto the shared canvas for the entire project team to use. So this thing would grow over time throughout the course of the project. And the other kind of advantage of that in terms of sharing work is that, again, if somebody has to take over someone else's portion of the project or portion of the geometry, they know what the basic building blocks are and they don't have to relearn someone else's system of laying everything out.
And so
Um,
those are all just clusters. Is that right?
they're all just clusters. They're all just clusters. So that like spaghetti mess that I showed earlier, that kind of exists inside the cluster to a certain extent, although I've taken some extra steps to label so people understand what each component is doing. Um, but it's less intimidating when you relate it to a piece of the building versus like, here's all these abstract geometry tools, like pick some and use them, it'll be great. Um, but I
So
maybe could have gone over this before the other piece because this is where you're taking those apart and seeing all those different ways you can make a point or a line or whatever.
So coming back into this, so you keep a shared canvas, and some of your training
Yes.
happens in that shared canvas, or
Yes.
can you walk through that?
It's 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 basically just a canvas that we keep in our project folder that says these are all the current tools that are vetted for the team to use. So if one of my team members comes up with like a really unique geometry situation and they develop a slightly different tool that can handle that, um, we put it back on the shared canvas and then other people can take that and borrow it and use it in their definitions too. And it provides an opportunity for everybody to see how everyone else is customizing the tools.
And is this project by project, or do you do it for the entire
This
enclosure
is
department?
this is project by project. There are some projects that lend themselves to reuse more than others. I think you kind of fall back into that pitfall of like trying to anticipate the needs of every project ever.
Yeah, cool. Thanks. No, I was just curious and thought
Yeah,
that was relevant.
yeah. So next, I'm going to talk a little bit about sharing. Um, and using the tools that are available in Grasshopper to make things that are shareable and easy to understand. So we do have standardized across the enclosure department. We have color coding for groups in Grasshopper that tell you what each portion of the definition is doing on a high level. So is it an input? Is it an operation? Is it a visualization? Is it an output? Or is it a QC piece? And you can also use this for like zones of a project or different types of of project elements. So instead of the crazy spaghetti definition, and this helps with both sharing and with teaching people. I've labeled every single thing in here and I've given this to someone on my team as a template. This one is for just a more simple curtain wall. Um, and like you can see that component in blue in the middle of the screen. Yeah, it's a surface being split with a curve, but I've added detail to say why I'm what the surface is that I'm splitting and why I'm splitting it up. Um, so I think that like if you've ever gone through and picked through somebody else's definition and tried to figure out what the heck everything was doing, it takes a little bit more time up front to label everything like this, but once you get started doing it, it kind of becomes second nature and people come back to you less frequently with questions about what all of these things mean. So in this case, my green groups are inputs that are coming from Grasshopper, not necessarily being referenced from Rhino. My blue are my operations. That red piece is a QC that I'll get into in a little bit. Um, so, and the next thing we want to talk about is teaching the data tree. So there was an amazing Your Desk presentation about the data tree, which I'm now going to send to everyone all the time. So I'm not going to go super in depth about that. I just want to bring it up as something that's really important and that gets people to the next level. Once people get the basic layout of the Grasshopper canvas and like the history of things and how you create simple geometry, I always say, okay, now learn the data tree because you're not going to be a super user until you do that. The
Yeah,
first time
huge
I
shout out to
watched,
Andrew for doing that session. And John, maybe we can get that posted in the chat window so people can reference it if they want. Yeah, that was
the
that
first
was
time I
like
watched a data tree
so
video,
so
my mind
helpful.
was like, so the way I start getting people into the data tree on projects is through our indexing that we use for interoperability. So we do a lot of interoperability with like analysis software for like steel framing and all of that. Or in the past, we've gone to Revit with like curtain wall panels and that sort of thing. So our interoperability tools require every piece of geometry we add an index that has some different little 2 or 3 character codes that mean something relative to the project. So this is a little indexing definition that's for curtain wall panels, and our indexing strategy are the last 5 characters of that index has a number representing the level of the curtain wall and a number representing the location of the panel within that level. So if I want to start tagging that stuff, I need the data to be in a tree. And so even if my team member is not that advanced and they've produced something that's like totally flat at the end, we can sort it again into a data tree and get them to understand like what you might use that data tree for. And this is a really simple, clear example. So in this case, I have 2 levels of curtain wall panels, and they each have 136 panels in them. Um, and then I can use this, I use the little definition to assign those unique numbers at the end. And so people pick up on that really quickly. Uh, and you can see right in Grasshopper, like, okay, these are all labeled correctly. So you know right away if your data tree has gone wrong, if it goes like 6, 7, 22, like something has happened that's not right. So it's an intro to get you into the more complicated data tree troubleshooting that you'll end up doing later.
You finding
Um,
that like to help understand data trees, it's helpful to like try to like label something and then visualize it in
yeah,
3D so that you can see, oh yeah, my like labeling schema, which is also a data tree, is working. Like that
yeah,
kind of what I'm
yeah,
getting out of that.
exactly. Exactly. It's really easy to see if it's working or if it's
Now
not
when
working.
we had talked before, you'd mentioned that there's another data tree series that you use. Can you mention
Yeah.
that?
It was David Rutten did a data tree series that I think was on Vimeo. I don't have the link right now, but I think if you Google it, it should come up pretty quickly. I usually just tell people to Google it because I never have the link
We'll
saved
try
in
to
the right
find it and
place.
get it posted. Thanks.
Yeah. So the next piece I want to talk about is troubleshooting. So every time somebody comes to you, I broke the grasshopper definition. What do I do? So again, it's really good to spend the time up front to sit and say, okay, you broke it because of this. Um, your data tree is messed up. So it's almost always the data tree, right? So you start with lists, and you can show people, okay, here's your two lists and your two panels, they match. And I also pepper all of my definitions with these little red QC things. I'm just checking to see if the list length is the same. And I also put a little tag of like what the output of this should be. So number of missing indexes should be 0. So somebody knows like, oh, if this is one of my surfaces didn't get an index assigned to it. I wonder what happened. And then you kind of work your way back through the definition and see where you lost something. And it gets a little harder to do in the panels once you get to data trees, because now I have 4 corner points of a curtain wall panel and 1 index to go with that. And then you can start using the param viewer. And in this case, it doesn't matter that there are 4 here and 1 here. So I can just check the tree statistics and see if they match. So this is one of my interoperability definition canvases. You can see it's got little red boxes like all over it. So each time I do a step, a major step, not every single step, each time I do a major step of inserting data into this thing, I check the tree, I check a couple of different things. And so if somebody else is using this and they see like this QC is good, but this QC is bad, okay, I know the error happened somewhere in between and I need to isolate the error. Because I think when you're new at this, one of the hardest things is isolating where your errors are. And so if you get people to like pepper their definitions with these little QC tools that don't take a lot of processing power to like check the length of 2 lists, it helps them isolate and see where kind of the repeated errors will come from. And this one's a geometry check. Another thing I'll see a lot on our facade projects is if you're like dicing up a design surface, you'll get itty bitty slivers of panels that are not actually valid. So showing people how to like check the minimum area of a panel, for example, and filter out, like in this case, I've got one panel that's too small and I can preview it in 3D. So really just like teaching people where to look for errors and how to find their own errors will save you a lot of time because they will spend less time tapping you on the shoulder and coming to your desk. Which brings me to managing your time. So you don't want to stay up all night. People come to your desk when there's not a pandemic and they tap you on the shoulder and they ping you on Skype, and it's great. And I love like sitting down with people and working through their troubleshooting issues and like helping them learn. And I love when like you see the light bulb go on in their head. But also I'm responsible on this project for delivering some of the more complex Grasshopper stuff like interoperability workflows or developing new tools or whatever. So I need time to like focus on my own work as well. And if you have 5 different engineers kind of sending you Skype messages every 20 minutes or so, that's really hard. So there's 2 kind of major ways to coordinate. One is synchronous, talking to people in person at the same time, doing tutorials, the people tapping you on the shoulder. And so what I did is, this is my calendar. I have a lot of meetings. I set aside at the same time every day, with the exception of our team meeting on Monday, I set aside office hours like your professors in college. And I just sit there on like a Teams call and people can call in and say, I have a question about this. Can you help me develop a tool to do that? And it's usually project based. So it'll be people within the project team. And sometimes a couple of people will listen in and they can kind of hear what each other are asking about and learn from each other. So I think this has been really successful. It both gives the more senior computational designers time to actually focus on their own work. And it gives our team like reassurance that they know we've set aside time for them to help them and walk them through this stuff. And we can also use it to call the whole team together and present new tools or any of that stuff. And then the other piece is when you need to collaborate, but you cannot find a time to talk to each other. And this happened to me recently when I'm on the West Coast. I was working with an East Coast project team and I had some new people that I really wanted to help out. Um, but someone would go home for the day. And so I could take a look at their Grasshopper, but they weren't there to walk through it with me. So I leave them notes. So this is an actual canvas from an actual project. And this was kind of also looks at what I was getting at about doing things the simplest way. You can see that she has like copy pasted the same like groupings of Grasshopper components a couple of times, and like that's fine if you're a beginner. You know, we don't need everyone to like be masters of the data tree at the very beginning. It's okay to reuse the same components a bunch of times. But what I did here is I went in and I adjusted one of them and I made it pink. So as soon as she opens it, she's going to see, oh, Laura left me a note. It's pink. And I zoom in on it and I've made a couple of little modifications just in this one sample. And I told her what I did and I told her why I did it, and how she might modify the rest of her definition to make it a little bit better. Um, so the scribble tool is like one of my favorite things. So I think that's mostly what I wanted to share with you guys, and I would love to hear if anyone disagrees with me and thinks I'm totally wrong, or has other tips for bringing new Grasshopper users up to speed, and how you guys have done things differently.
Yeah, thanks. I haven't seen any questions come in the chat yet, but I did have a couple that came up for me. Can you talk about maybe some of the people that you're training in Grasshopper and what is their thinking when it comes to like, there takes a certain amount of computational thinking, and like what's their background in that? Do they come with like a lot of that? Do they come with interest but not really like the know-how, the logic understanding quite yet? Where you know,
I think so I
it
work with a
obviously
lot of
varies, but
architects and engineers, obviously. So I think it in particular varies across architects and engineers. So I found that like a lot of architects have maybe had a little bit of experience with Grasshopper in school, but with architects and with design, like especially when you're in school and you're working on a studio project, it's kind of plug a bunch of stuff in and see if something cool comes out, right? And so that's really great. If you're trying to create interesting novel forms, it's not so helpful if you are trying to get a really precise facade system put together and take that from a design software to an analysis software to a coordination, to like a Revit or something. Um, and then the engineers like don't generally, I the ones coming straight out of school like don't have any Grasshopper experience, but they're pretty good at like the computational thinking end of things.
because I found it's a
So it's
lot
kind of a
easier to
mixed bag.
onboard people who already kind of have overcome that. Also, before we get further into the Q&A, which I'm still waiting on more questions if they come in, but don't forget to hit that like button. If you like what Laura did, um, hit that because that really does help other people find it easier, and that's the best way to get the word out on your part. And then obviously we're still watching for questions, but yeah, I found that if someone already knows like a little bit of computational thinking, it's easier to onboard them. And I usually
Mhm.
start with like trying to understand the logic of computation if they haven't done it at all. And oftentimes, if we're starting at that point, I'll oftentimes start with like working with strings before I even get much into geometry, and then working with basic geometry connections before I get into the abstract geometry. It was interesting that you kind of proposed starting with abstract geometry, um, or maybe you were saying like once you already taught them some Grasshopper, then you encourage them to start with abstract geometry. Um,
Yeah, and I think that's what it is. You kind of, and maybe I didn't mention this at the beginning, but you can start with like some basic tutorials that teach people, how the canvas works, where stuff is. But a lot of times those aren't um, they aren't always relevant enough to the specific work that you're trying to do, that you can get people to just do a tutorial and then do a project without anything in between.
getting getting thanks. Yeah, what are the main issues you found that people struggle with? We talked about data trees, without saying that as a general topic, but just kind of the variety of different topics. Can you say anything about what kind of main
Um,
issues that people coming into Grasshopper and just starting out, like what are they running into?
let's see. A lot of stuff with vectors. People tend to have a hard time with vectors, especially if they've come from modeling where you just, select a tool and click things. Um, I mean, like when I got started, I was using different parametric software before I got into Grasshopper. So I felt like that gave me a really good foundation. Um, but the idea of like the whole history of everything, and that like you have to start with a point before you can define a line, before you can define, so like the building up of all the layers of everything. Um, but yeah, and a lot of data tree.
Mhm. Do you tend to lean more heavy into like add-ins or extensions, or do you try to stay um, just with like core components?
It really depends. I have a lot of add-ins that I use. I didn't talk about any of them in here because I wanted to keep it really simple. I guess the problem with add-ins is if somebody like stops developing it. Uh,
But
but
I guess with
yeah,
regards to
there's a
like
lot of.
training, I know we all of us, everyone ends up using some extensions or add-ins or has like favorites. Do you find that there's a time when it's best to start extending beyond the out of the box components?
I don't know if I have anything kind of universal to say about that. I think it just when it makes sense for the work you're trying to do. I mean, like everyone has Lunchbox, for example, right? I almost consider that like a base part of Grasshopper. Um, so
Yeah.
yeah, I don't
All
know.
right. We got another question that came in. So how do you prefer to share Grasshopper files? And so question number one, how do you share Grasshopper files? Second, and number two, how do you handle version controlling?
That's a great question. So we don't necessarily like have different people sharing the same Grasshopper file. So like a lot of these projects we would divide the building or the project or whatever into zones and have each person own one zone. So on in that sense, it kind of it helps with like the work sharing without having to work share on the same file. But it's a little bit boring because we kind of just want people to keep the most up to date version in the folder for the project.
And do you keep a
And
backup folder or do you
yeah,
like
I keep a
append
backup
it with like
folder.
V1, V2, V3? Do you use anything inside of Grasshopper to like help people know that?
We keep a backup folder and we'll like append a date stamp if we think that this is like we're making a critical change. Then I'll save a copy and append a date stamp to it. I've also experimented with using externally referenced clusters for like things that are universal across the project. So we had like some levels that we wanted to share across zones, and I tried like putting those level planes in a cluster and externally referencing it so that if someone updated the cluster, like everyone's levels would update. Um, with mixed success, we also tried clustering some of the standard tools or components, not necessarily like the base geometry components. But for example, we had one that like optimized kickers. So we knew all of these members needed a kicker on them, and so we had one that would like pick the best kicker for each. So we tried doing something like externally referencing that one, so that if I found a better way to like make that component run a little faster, it would update for everyone. But I've had kind of mixed success with that, and I don't know if I would do it every
Yeah.
time.
Yeah, I mean, actually, it's a great question to the room too, and we're getting close to wrapping up here. But like, have you what's your success rate been with externally referenced clusters? Because I know the structures, which is where I'm at. Um, we do that with some also. And everyone there's always some clusters you're doing internally, some clusters you're doing externally. They're user objects, people developing C sharp components, kind of on the higher end when you like really know you're going to be doing the same thing over and over and over, and seem to be easier to share across across scripts. Yeah. All right. Let's see. Oh, so you talked a little bit more about that template. I kind of wanted to dig a little bit more into that. So I'm assuming these templates are copied across projects, uh, and like or you have like a all like a template of templates.
Do you mean
Those
like
sharing
the
templates that you were
the
talking about.
canvas with the components on it,
Yes,
or
thank you.
just like
That's your term, the shared canvas.
I have a bunch of them. I have like a personal one that I've saved that has just some silly little like data processing clusters that I find myself rebuilding over and over again. And so I'll save them onto that. But yeah, we'll do them generally project by project because I think every project has its own kind of quirks. And there will be a couple of different ones for each project. So there will be one that's about data processing tools. We had one that was about the primary structure components. We had one that was about secondary structure components. So
And that can
yeah,
kind of
I
help
think
people. It can
it's
help
mostly
people to
just
like have
project.
something to start with sometimes.
Yeah, exactly. I'll also sometimes just give someone, instead of a cluster, I'll just give them a template like I showed on my slide that has everything detailed out of what I'm doing and why. And then I say, okay, start here. This is not going to cover every situation for you, but this gives you a place to start and a place to build off of. Because even when I write my own stuff, I usually like go back to another project and copy paste something and modify it, because why do everything from scratch every single time?
Yeah. Oh, thanks. All right. Well, with that, we're going to close. Thank you, Zach Cron, for your question. Thanks, BVR, for all the links that you posted for the Grasshopper things. Thanks for everyone else who was involved in the chat. Laura, thank you so much for the time you put into this. And with that, I'll see you guys next Wednesday again, same time.
Thanks, Timon.
Oops.